Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have seen the definition of deterministic finite automata. Now we will see certain problems and we will try to construct deterministic finite automata for these problems. The first question is constructing a deterministic finite automata on the given alphabet 0 and 1 which has at least a length of 3. So let's see this. The first state is Q0, which is taken to be the initial state. As you can see in the diagram, we have taken 4 states, Q0, Q1, Q2 and Q3. Now, the input starts from the initial state. How initial state is designated in a state diagram? The diagram which I have shown now is called the state transition diagram. The initial state is shown using an arrow which is coming from nowhere. Now, the input symbol that we apply starts from Q0. Let's say we have applied the string 001. On applying 001, you can see the input string will start from the initial state Q0. On applying 0, it will have a transition to Q1. Now on again a 0, it will have a transition to Q2, and on the last one, it will have a transition to Q3. Now this is a final state which is designated using a double circle. Now this means that 001 is a string which is accepted by this DFA. One more example, let's say 01. Now on applying 01, the first initial state will be Q0 again. Using a 0, it will have a transition to Q1, and using a 1, it will have a transition to Q2. Now Q2 is a non-final state, hence 01 is a string which is not accepted by the particular DFA, and 001 is a string which is accepted by the DFA. Now we have seen the state transition diagram. Let's see more representation of the same DFA. The table I have drawn is called the state transition table. Let's fill the state transition table using the DFA we have just constructed. Now, as our example says, at least it should be 3. More than 3 is also accepted as an input. Hence, we need one more transition at Q3 which should be accepted by any string which is having more than length 3. So the last transition shows that even if the string is having length more than 3, it will be accepted. In the state transition table, how to represent the final state? It is represented using an asterisk mark on the state. You can say that the DFA is constructed using all the components. Now let's discuss the components. We have seen the components of the DFA are as follows: Q, sigma, delta, Q0 and F. Let's say M1 is the machine we just designed. We have Q, sigma, delta, Q0 and F. Out of them, what is Q? Q is the set of states. And which are the states we are using here? Q0, Q1, Q2 and Q3. Sigma is the alphabet we are using, so we have 0 and 1. Delta, as you can see, the transition function is already stated in the transition table. Using that, we can define delta. We have seen various forms of this particular DFA. We have seen the state transition diagram, we have seen the state transition table, we have seen the transition function. Now let's see the rest of the component. That is, we have defined delta. Now let's see the initial state and the final state. As we already discussed, the initial state over here is Q0. We have discussed Q, we have discussed sigma, we have discussed delta. Now Q0. What is F? F is the set of final states. Now which are the final states over here? There is only one final state, that is Q3. So here we will have Q3. With this, we are done with the first example. Let's see the next one. We are designing a DFA for accepting the language of containing strings at most 3 length. Again, Q0 is our initial state. We start with Q0. On accepting first alphabet, either 0 or a 1, we will have a transition to Q1. Again, having 0 or 1 as the input, we will have a transition to Q2. Again, having an input 0 or 1, we will have a transition to Q3. Now, what is the question? The question is, it should have at most 3 as the length. We know that 0 length is also final, length 1 is also final, length 2 is also final, and length 3 is also final. But if the number of inputs are exceeding length 4, then this is a non-final state. Now, after the fourth alphabet, even if a number of input alphabets are coming, it is never going to have a length at most 1. Hence, the last step is a non-final state. Let's see again the definition. We know that, let's say this is machine M2 having Q, sigma, delta, Q0 and F. So what is Q? Q is the set of states. Set of states over here are Q0, Q1, Q2, Q3 and Q4. Sigma is the alphabet, which is 0 and 1. Delta, let's draw the transition table. From Q0, Q1, Q2, Q3 and Q4. The final states are Q0, Q1, Q2 and Q3. Initial state is Q0. On alphabet 0 or 1, these will have a transition from Q0 to have a transition to Q1. From Q1, it will have a transition to Q2. From Q2, it will have a transition to Q3. From Q3, it will have a transition to Q4. From Q4, it will have a transition to Q4 itself, because now this is a non-accepting state. Non-accepting states are also called as dead state, because there is no incoming to any final state after trapping into this state for the given input. We have defined Q, we have defined sigma, we have defined delta. We know that Q0 is the initial state. Let's see the final states. Which are the final states? Out of the given state, Q0 is a final state, Q1 is a final state, Q2 is a final state, Q3 is a final state, Q4 is not a final state. Let's see the next example of designing a DFA which accepts strings of exactly length 3. We have already seen at least length 3, at most length 3. Now see exactly length 3. Again, we will start with the same, that is Q0 as our initial state. Hence, we will have an arrow from nowhere. Now, this is having 0 or 1 as an input. It will have a transition to Q1. Again, on the input, it will have a transition to Q2. Now it is length 2. One more alphabet, length 3. This is the final state. Why? Because here we are having a length 3. Now, if the length exceeds this, that it has to be non-final. So Q4 is non-final here. Again, let's say this machine is M3. We have Q, sigma, delta, Q0 and F. What is Q? Q is the set of states. Here the set of states are Q0, Q1, Q2, Q3 and Q4. Sigma is again the input alphabet set 0 and 1. Delta, we are going with the table, that is from Q0, Q1, Q2, Q3 and Q4. What are the transitions on the given input alphabet set 0 and 1? We will mark initial state and final state. The final state is Q3 and the initial state is Q1. On 0, Q0 have a transition to Q1. On 1 also it is having a transition to Q1. Similarly, Q1 has a transition to Q2. Q2 has a transition to Q3. Q3 have a transition to Q4. Q4 has no transition because on length 4, whether it is 0 or 1, they will not have any state which is final further. So it is having Q4 only. We have seen Q, we have seen sigma, we have seen delta using the table. We have seen Q0 as the initial state. Let's define the final states. Final state is Q3. With this, we are done with the example of constructing a DFA for accepting strings of length exactly 3. Let's start with the initial state Q0. We need odd length. Let's say we have an input 0 or a 1. Now what is the length of the string? The length of the string is 1, which is odd. So the state over here has to be a final state. Okay. Now let's say we get one more input 0 or 1. Now what is the state? That state is again going to an even length rather than an odd length. So we will come here back. You see this? Now let's say the input string is 001. So 0 have a transition from Q0 to Q1, 1. Then let's say next 0, 001 is the input. So 0, 0 and a 1. You see on 3 you're going to again a final state. Let's say 0001. On 0, 0, 0 and 1 you'll come back to a non-final state. Now this is a DFA which will have the set of all string having odd length ending at Q1 and set of all strings having even length ending at Q0. That means all odd length strings will be accepted and all even length string will be rejected. Let's see this machine. Let's name this machine M4. Let's see what is the definition. Q, sigma, delta, Q0 and F. What is Q? Q is the set of states. Here the set of states are Q0, Q1 and Q2. Sigma is the input alphabet set which is here 0 and 1. Delta is again expressed using transition function. Let's say there are two states Q0 and Q1. On the input alphabet 0 and 1, Q0 is our initial state, Q1 is our final state. We mark them. On an input alphabet 0, it is going to Q1. On 1 also it is going to Q1. From Q1 it is coming back to Q0. We know that Q0 is the initial state, so we have done with Q, sigma, delta, Q0. What is the set of final states? Set of final states are, there is only one, that is Q1. There is a particular question which asks the number of minimal states required to design a DFA of various given question. We have already seen 4 questions. The first one was having a string of length at least 3. Let's say a general case of length at least n. Similarly, length at most n and length exactly n. How many states are required? We have seen that with length exactly 3, at most 3 and at least 3, it was having 4 states for at least 3, 5 states for at most 3 and exactly 3. Similarly, for a length n, we will have n plus 1 states with at least length n plus 2 states for a DFA having at most n, and n plus 2 states for a DFA having exactly n. With this, we are done with few examples which are easier for designing a DFA. We will see more complicated examples from the next video. Thank you for watching. Stay tuned to Ekeeda channel and do subscribe to the channel.